Good morning, everybody. This is Gopi Mamidi, working as assistant professor in Sri Rama Institute of Science and Technology. Today, I would like to explain about full up to full down ratio. Full up to full down ratio for an NMOS inverter driven by another inverter. This is we are going to discussing. You know very well what is the inverter and this working operation. Okay, it is inverter number one. It is driving the inverter 2. I am applying input here. It is the output. It is the inverter 1. It is the inverter 2. What happened? What is full up full down ratio? What is resistance in the channel? Z is equal to length by width. Z is equal to length upon width. One by Z is equal to width upon L. Got my point? If I am reciprocals equation number 1, I will get 1 by Z is equal to W by L. You know the inverter circuit. NMOS inverter. NMOS inverter, it is look like this. It consisting of the depletion mode transistor. It is the full up network. It consisting another NMOS inverter, enhancement mode network. Just let us with taking output across here. It is the full down network. The impedance for this full up network Z full up is equal to L pull up by W pull up pull down pull up for resistance for this network pull down network is equal to L pull down by length of the channel of pull down network by width of the channel of the pull down network ratio. Just these two are the ratios of this one. What happened? In saturation region, it acts as a transistor. IDS, we already derived IDS equation. Drain to source current in an inverter in a MOS circuit is equal to K into W upon L VGS minus VT whole square. I am taking it as equation 1. let I'm taking depletion mode transistor. Depletion mode transistor. In depletion mode transistor, in that specially saturation region. In saturation region, depletion mode transistor VGS is equal to 0 volts. When VGS is equal to 0 volts, then this IDS will become a. I am putting VGS value in the equation 1. Then that equation will become K by W upon L 0 minus VT whole square. Therefore, IDS is equal to K into which network? Depletion mode network. It is a pull up by L pull up. Okay na guys, please give me little time. Pull up network minus VTD because of threshold voltage of depletion mode transistor. I am taking this whole as equation number 2. Then for the enhancement mode transistor. In enhancement mode transistor, I am taking VGS is equal to V inversing voltage because of in the inverter of MOS transistor, pull up transistor means depletion mode transistor is always shorted source and gate, so it is in always condition. Here the input is inverting, that input voltage is applying across the enhancement mode transistor, that was the inverting voltage. So I am taking VGS is equal to V inverting voltage. This voltage VGS is inverting for which? Enhancement mode 1. So I am applying VGS is equal to V inverse in the equation number 1. So substitute VGS in equation number 1. Then equation number 1 will become IDS of enhancement mode transistor K into for which transistor? Pull down transistor by LPD into VGS is equal to V inverting minus VT whole square. I am taking this as equation number 3. In equation number 1, IDS. In equation number 2, IDS. Is these two are the equal, so sorry Nana, it is 2, it is 3. So simply we can say from 2 and 3. From 2 and 3 what we can write? From 2 equation K W pull up by L pull up in minus VTD whole square is equal to K into WPD by LPD V inversion minus VT whole square. In this one, here and here, k same. I am cancelling those two. Okay now guys, we know one thing. Initially, I am saying that W by L is equal to 1 by G. Therefore, I can write it as 1 by GPU, and I can write this combination as 1 by GPD, impedance of pull down network. So this one will become like this. So I can write ZPU minus VTD whole square is equal to V inversion minus Vt whole square into give me a little space here. One by ZPD. So I am bringing this one, whatever, either this one, I am bringing this one to this side, this 1 by ZPU to which side? Right hand side. Then and V inverse minus Vt whole square into left hand side minus VTD whole square by whole square by V inverse minus Vt whole square ZPU by ZPD. We know it. What you have to do? I am bringing this whole square to right hand side. Then that will become a minus VTD by V invert minus Vt is equal to under square root of ZPU upon ZPD. What will do? What we have to do next? We have some typical values that VTD, the value of VTD VTD is equal to minus 0.6 VDD and V inversion is equal to V 0.5 VDD and Vt is equal to 0.2 VDD. I am substituting these typical values in the above equation. Then this equation will become so minus of minus plus 0.6 VDD divided by 0.2 VDD minus 0.2 VDD equal to PU upon ZPD. What happened? 0.6 VDD by 0.5 minus 0.2 will become a 0.3 VDD is equal to square root of ZPU upon ZPD. Here VDD will get cancelled. 0.32 times how many times? 2 times. How many times? 2 times. It will become a 2 upon 1 is equal to ZPU by ZPD upon whole root. Whole root. I am squaring on both sides. What happens if I am squaring? It 4 by 1 is equal to ZPU upon ZPD. Therefore, the ratio of ZPU is to ZPD is equal to 4:1. This is the full up to full down ratio of an MOS inverter driven by the one another. Guys, I hope you